Welcome to the CSC 578 final project walkthrough. So, we're going to start out with restarting the kernel, running through some things. Import the data set, do some basic exploration to get the shape and some visualizations, see what's happening. I like getting to see what's going on. Then we have shape. Visualize the columns. So this is going to show a nice plot across time of everything. There were a couple outliers in the wind velocity variables, so I took an average of variables that had like similar other parameters and put that there instead, because the values were like negative 9,999, so that was obviously incorrect. Maybe it just didn't record for those years. So I did that. Otherwise, you can see some trends happening. So that's nice. See how temperature is related to dew temperature. Also, things like the density is sort of inversely related. So that's nice to know. Moving on, we're going to ensure all of the variables are afloat. So this is my training model based on years. We need a little bit of the day before down here in order to predict the next day from the first. So we do that. For reference, we're just going to take a look at things to make sure we have the correct start date and end date, because that was a bit of a struggle. We have the right amount of rows and columns. Now we're going to normalize the features because they're all in different units. I used range -1 to 1 because that was good for tanh. Still the right shape. Now we're going to normalize it in viewing. Take a look. So this really nifty bit of code I got from Jason Brownlee in multivariate time series forecasting, and it basically did what I was trying to write anyway, but it's a very nice little function, and it shifts everything so that you have t minus whatever number you're looking for. So this is reframing all of the testing and training data, and this is so we can take a look at it. See, variable 1, t minus 24, variable 2, t minus 24, and it goes all the way through variable 14, t minus 24. And here we have all of the rows. We have to make the single vector for y because it's just the temperature. So here we go. Right number of rows, 1 column. Got the whole shape for y training as well. Now, some of the columns we don't want to predict because we're only predicting temperature, not wind speed, etc. So we have to drop those so that we only get the variable for temperature. Sorry, the thing is in the way, variable 1, t. Now we just need the values. We don't need this formatting, the data frame formatting. So we're reframing the shape. And then, as you can see, we have the right number of inputs for training x. This is the shape, training y shape, training x shape, and training y shape. Now we're going to design the network. My network was really awful. This is the basic one. I could not make it better. I think it has something to do with the 24-hour sliding window that did not work out. But I tried a wide variety of things. They all did bad. So we're just sticking with the basic network because it did the best. Maybe it produced the less errors in this case. If you have any ideas, I would love to hear them. Because I spent a long time trying different things and having it not work out. So now we're going to start the fit. I'm going to pause it while it runs through all the epochs, and then we will pick back up. Perfect. So the training is done. We went through 30 epochs, and the loss is clearly very small, so that is good. We're going to plot the history. See right here. However, though it decreases right away in the training data, the test data is all over the place. So it's like very small changes based on the loss because as a regular number, the loss is very small. So then we're going to look at making a prediction. We're just testing to make sure things look good here, because I like to see things. So make a prediction. We have to invert back the scaling that we did, so that our predictions are meaningful. And then we're ensuring that we have the proper form for calculating. Here we have the RMSV, which is also very low. And then let's plot the predictions. So the predicted on this is actually just slightly higher than the actual. This is much better than before I got rid of those outsider data points, because before that my predicted was chronically lower. But now it seems to be making sense. It doesn't, based on this graph, it is a relatively decent model. But I output it to the CSV file, and then when I put it into the Kaggle competition, my score is horrible. It is the worst out of the bunch. So I feel like I am doing something correctly and something incorrectly, and I'm not quite sure what. But overall, this is great. This looks how I want it to look. So I feel good about that. Thank you very much. Let me know any of your suggestions or comments, please. Have a great one.